There is no one in the waiting room anymore. Yeah, so maybe let's just start. So hi everyone. Thank you for joining us online. So now we can maybe start just with a key fact. According to the estimation of the industrial organizations, around 20% of the total industry energy consumption only comes from the drying process. So for some industries, it's even higher. If we take, for example, paper, I see that some of the guests are coming from this industry, a product mainly made of water and cellulose. Then the drying section is the most energy intensive because it represents more than 80% of the total energy used in paper making. So I'm sure everyone is interested to see how to reduce this energy consumption. And yeah, at TEWS, this is something we have worked in the past. Now, with the energy crisis that Europe is facing, the question is not shall we reduce our energy consumption, but how can we do it? So that's why today we're hosting this event, because at TEWS, water is the core of our activity. And yeah, this was a topic for the previous months. So I decided to gather teammates from TEWS just to let you know, webinar is not our expertise. It's only the second time for us to do something online. So I hope you will all be understanding and that you will enjoy. So today I invited two people with me, Henrik.
Hi, everyone.
Yes, hi, Henrik. You're a physicist and you're working with TEWS R&D for 18 years now.
That's correct.
And you're finding new solutions for our partners. You're also playing around with data analysis, and you're our internal data scientist.
Yes, that's right.
Okay. So thanks for being here, Hendrik.
Welcome. It's my pleasure.
And Ingmar. So Ingmar is the head of our customer success management team.
Hello to everybody. Yes, my name is Ingmar, and yeah, it's also my pleasure to say hello to the people from America for this, for this webinar.
Yeah, that's right. Good morning to the people from America who are joining us right now. I'm just finishing adding people in the room. So Ingmar, you and your team, you're the main contact to our partners when it comes to installing the solutions, finding good installation spots, training the tools to run correctly, and of course, following up with the results of our solutions on the customer lines.
Yes, that's correct. That's what we are focusing on.
Okay, great. Thank you, Ingmar. So as a matter of fact, energy consumption is currently a real pain point for most industries. And when we are discussing with our partners, we are finding out that most of them are using gas-run dryers, which is quite a problem today. And some of them are even willing to switch to oil-operated dryers. Yeah, when it comes to drying, the objective is always the same: removing the water from the product. So maybe, Henrik, can you tell us through physics eyes what happens in the dryer, no matter its shape or no matter the process? Why is it so energy consuming? And maybe how could we help to reduce this energy consumption?
Yeah, sure. Welcome. So, of course, I won't go into the details of physics too much now. I mean, it's a passion of mine, to be honest, but I mean, everybody who's sharing this with me is, of course, welcome to discuss this later on, if you like. So, okay, the goal of the drying process is, of course, to remove water from the product to achieve a process-specific target moisture. And our technology allows for controlling this process, either backwards, as you see on the picture, measuring right after the dryer, or even upstream to the dryer in some situations too. Yeah. Mm-hmm.
Okay, but I think there are many ways to control the water, the moisture.
Yeah. I mean, first of all, it's clear that without any measurements, an optimization of the process is not possible at all, right? So to determine the moisture can mean just taking samples from the line, like the lady here, or using smart sensors like ours. Yeah.
Okay, and so maybe can you illustrate furthermore?
Yes, of course. We have a little animation here to illustrate this a little. So what we see here is a standard drying process. It shows how the moisture content of the material decreases over time. And as we can see, since the curve is getting less and less steep, the drier the material becomes, the longer it takes to further reduce the water content, right?
Mm-hmm.
And thus, the more energy is required to remove also the very last water drops. So there is a point in time, of course, when the water content is supposed to, the drying process is supposed to be completed, when the threshold is reached, like here, for instance. Now, in order to ensure the required quality, and in this context to save energy, we of course want to stop the drying process just right in time. Means as soon as the threshold value is reached, right? And for this purpose, of course, we need some method to measure moisture.
Mm-hmm.
And yeah, well, as said before, this could be just taking samples from the line, take them to the lab, dry them down to zero in an oven, uh, wait for the results to come back from the colleagues, in the lab. But of course, this is quite time consuming, and this is time we do not have. This is also energy intensive now, right? So instead, of course, online measurements provide the results much faster, and yeah, that's the reason why those are really mandatory here in this situation. Now, the fact is that every measurement method, whatever you take, has its own specific measurement uncertainty, right? Indicated by this circle here. Yeah.
Yeah.
And mm, to illustrate this a little further, we see a so-called normal distribution here on the right-hand side, also called a bell curve,
Mm-hmm.
which should give us a better imagination, maybe about the margin of error of a method, right? By the width of this little bell, and this is a measure of the accuracy or precision of our devices, right? And now, yeah, if we want to be very sure that the threshold is already undershot, we have to wait until the majority of these measurements, not only a little bit, not only half, but a majority, are really well below the threshold. So to be able to stop the drying process as soon as possible, we need to use a measurement device as accurate and precise as possible, right? And in this example, I've given for a microwave device as provided by us, by TEWS. So we can see on the right-hand side again, there's a little a new Gaussian distribution. This
The
is
blue.
now, yeah, narrow. It's narrowed down because it's more accurate, so it fits earlier under the threshold. And if we recall the energy curve, we see that the energy consumption can be decreased tremendously by that for many situations. And you will give us an example or two later on, right? Yes. Yeah.
So you're insisting on the accuracy, and I understand that the more accurate we are, the earlier we can stop the process, and then the more energy can be saved at the end of
Yeah.
the day. So it's all about accuracy. Maybe we could give our guest a short explanation. Why is TIFS technology more accurate to use than other measurement methods?
Mhm. Yeah, well, that's because of the very nature of the microwaves you use. Microwaves, they are completely penetrating into the core of the material and not just measure the surface, like it's the case for NIR, for instance. So the microwave measurements represent the material on the conveyor, which we measure much better in comparison. And for the same reason, the method is also not as sensitive against environmental conditions, like varying air humidity or varying temperatures, which mainly affect the surface of the material, right? Pretty quickly sometimes. But the core would be unaffected by this, and we measure the core. So again, our methods really represent the material much better. And another important reason is that our technology can measure the moisture regardless of how much material is currently on the conveyor. It means on the sensor, and even regardless of how dense the material currently is. This should be clear and simple, but it's not the case for every device on the market. But for us, and this is a great advantage of our technology, especially in comparison to the so-called capacitive methods. So to sum it up, it's really the very nature of the microwave frequency range, which is just very, very well suited for all these types of applications.
Oh, precision, huh? So in order to see how precise moisture control enables energy saving, I suggest that we take a few examples directly from our industry partners who were kind enough to share some data with us. Just before that, maybe one thing, some of you may have questions. So I suggest that you find this little box on your screen. And whenever you have a question, you can type it. It will be anonymous. We will only be the ones seeing it and your name. And of course, at the end, in a few minutes of our slideshow, we'll take some time to go directly answer your specific questions. So feel free to ask them. So Ingmar, over the past year, I know you have helped many industries to optimize their process, and you prepared example for today. We checked together the guest list, and you took examples from the industries where our dear attendees are coming from. So wood, building material, food and pharma industries. Okay, we have new guests coming in, so welcome to the latecomers. Anyway, we'll be happy to share again what we have shared already. But now we're focusing on concrete examples from the industries. So shall we start now with wood, for example?
Yes, Alex, very gladly. So we know from our wood manufacturer partners that to dry, for example, 1 ton of wood, around 40 liters of oil is needed. So legal norms oblige companies to make sure that the wood or certain products made of wood are below a particular limit of moisture.
Mm-hmm.
So as an example, we can take the wood pellet industry. So wood pellets are classified in different qualities. So for instance, the DIN Plus pellets, which is it's a European standard. For them, the moisture has to be below 10% water content.
All right.
So in the global manufacturing process of wood pellets, there are different places where we can control the moisture and for the finished pellets, even the density. So regarding control of the energy consumption, it is interesting to install a sensor right after the dryer, because obviously the dryer has the highest energy consumption. So because of this, because this is the main spot, to influence the final moisture of the pellets.
Okay.
So what we use is a planar sensor with a flat surface. So you can see it in this picture, and it looks like a plate. So it can be installed very easily within the flow, and it will not be an obstacle for it. The product is just flowing over it. And this is the most accurate sensor to be used in the wood pellet industry. So the sensor sends and receives the microwave that penetrates the pellets, which are flowing over it where it is installed. So for instance, typical installation spots are chutes or hoppers or something where the product flows, so where it is in permanent movement. And the sensor is connected to an evaluation unit, which is nothing else but a CPU, a processing unit, which calculates the signals of moisture, density, and temperature being transferred to the PLC. And in the PLC, the values, the measurement values, were processed as an information to adjust the dryer automatically according to the received signal. So that is a kind of dryer control loop at the end of the day.
And before using TEWS, the control of the pellets were done manually. So the people were taking it from the line and go to the lab. So by the time they got the result, obviously the pellets, they were over-dried, right?
Yes.
So I think that was quite an improvement for the wood partners that we have.
And maybe as an addition to this, so of course, when the pellets have to be below 10%, it doesn't make sense to dry them down to 9, 8, or even 7%, because this is, of course, pure energy, waste of energy.
Yeah, if you remember the curve and the last water drops hard to remove and energy consuming, then of course 10 is already right earlier in the process. So we can imagine the improvements with the correct measurement method. And I wanted also to take the example of another industry, the gypsum industry. We have worked with in the past because they have very complex dryer to manage. And maybe you can say a few words.
Yes, that's right. So here, our customer, or one of our customers, one of the major plasterboard manufacturers, uses a multi-deck dryer. And thanks to the measurement of our planar sensor at the outlet, we can measure inline the moisture of each board, the weight per area, and the temperature. And the outputs can even be configured that we transmit, besides the average values, also the profiles of every single board. So it's really like we cut the board into single pieces and we measure a real profile. And this can be seen here in this screenshot. So our customers can even track wet spots left inside the boards, invisible for the eyes, of course. And this is caused by incomplete drying.
Mm-hmm. So what can happen with the dryer when we get this defined?
By values to the dryer PLC, the airflow can be adjusted accordingly with the position where the board was in the dryer. And in addition to this, and that is important of energy savings, of course, the boards do not need to be over-dried because of our high measurement accuracy of more or less 0.1% or sometimes even better. So they can be dried right on target, not too wet to avoid scrap and not too dry to reduce energy costs.
Very nice. And yes, adjusting the airflow is much more efficient than just raising the full dryer temperature, of course, and risking damaging the other boards who were themselves perfectly dried already. So, okay, that's interesting. Now, let's speak with data, maybe. I am sure our guests are interested to know how much energy can we save, and maybe also how much money they can expect to save with our solutions. So I think most of people know that TEWS is strongly involved with the food industry, and one of our customers was kind enough to share with us the real data from production.
Yes, so in this case, also for legal and quality reasons, the product's moisture level must be below 12%. And our partner was drying it down to 11% to be sure to reach the legal norm. They invested in our solution and decided to test the first year with a planar sensor installed right after the dryer. And as you see here, just raising the level of moisture from 11.0 to 11.2, so just 0.2%, so to be still on the safe side. And the time saved with inline measurements enabled them to increase the productivity of 2%. So just by increasing the moisture level from 11 to 11.2. So the benefit of this productivity increase regarding the price they sell the product was 90,000 euros for the first year already.
So last but not least, because maybe we should try to keep some time for the Q&A, as we closely work with the pharmaceutical industry, and this industry is very demanding in terms of standards, we also have with us an example from a partner from this industry.
Yeah, the example from the pharmaceutical industry is really interesting. So for the producers, moisture levels are not only a mean of legal requirements, but also incredibly important in regard with the efficiency of the medicine produced. And when the batches are overdried, they cannot be reduced nor thrown away in a simple bin.
I see. Yeah. So let's check.
So inside the fluid bed dryer, the machine, which is the machine that dries powders or very small pellets. So this avoids to the laboratory to interrupt the process, take samples, waiting for the results, and then turning on the process again and again, stopping, measuring until the right moisture is reached. So it usually means around 10% energy consumption, but also up to 75% time savings of manual work in the lab.
All right.
So production data with us, they saved 300 hours in a year, and this means, in this particular case, plus 190,000 euro regarding the price of the material, of course, and the handwork, by investing around 100,000 euro for 2 TEWS sensors. So as you can see, the ROE is obviously very good.
Yeah, and let's imagine the year after the investment, when there is no investment to do, then the benefits is even higher, because the nice thing is once the system is set, it's running for years.
Yes, that's correct. So our systems are almost maintenance free, and there's no requirement to recalibrate them from time to time. So the calibrations are very long-term stable, and some systems in these applications run for even 20 years or so with the same calibration.
Okay, great. So I see that we had some guests that just arrived a few minutes ago. So I'm sorry you missed the part, but we wanted this webinar not to be too long and keep some time to answer the questions. So you remember there's a Q&A box where you can ask your questions. We'll focus in replying to them. Let's just synthesize the measuring with accurate and precise tools. The moisture after the dryer will enable you to either reduce the time spent in the dryer, the temperature, the airflow, and this will lead to the energy optimization we are looking for. So the best way to check the technology, how it can help you, and is to study the return on investment. For this, we have a small tool at TEWS. I can just introduce it to you. If you come with us with some data from your production, and you can provide us with the following elements, like the dryer energy consumption, the level of moisture of the incoming product, and then your target moisture at the end of the process. Following elements, then we can calculate with you the potential expected energy savings at the end of the day. We can also estimate material and labor savings regarding your main goals. So just come to us if you want to discuss in a more private discussion, because obviously today we will not have you share your private production data. I will just put a link. I think all of you may see it here. There's a link. You can directly see our calendar and book a call with us. We are happy to plan this with you. Okay, so we have a few questions now. Let's check. So what are the shapes of the sensors? Can they fit in any line?
So I would say this is a question for me. So I would say it can fit in almost every line, because we have different sizes of sensors. And when we talk about size of sensors, we always talk about a round-shaped sensor, and it starts with a diameter of let's say 40 millimeters, or maybe a little bit less than 2 inch, and it goes up to 160 millimeters, which is more or less 6 inch. So this is our range of sensors. We have different ways to mount it in the line. So we can fix it with screws, or we can also fix it with tree clamp constructions. So there are many ways. So I wouldn't say that we can fit the sensor everywhere, but almost everywhere. So that's possible. Just let us know where to install, and we find a solution.
Yeah, usually in the process of the discussion with new partners, we have to see the production line, and this is the work of Ingmar's team. So I see another question from someone who might have had some trouble in the past with the maintenance. And how long does the sensor last on the line? What is needed to make it run? So I think you partially answered the question earlier, but
So how long does it last? So this depends. This depends on the product. It depends on the properties of the product. I would say, as a rule of thumb, the planar sensor lasts for 10 years or more. And what is needed to make it run? It has to be installed mechanically, of course. So we have to find the right spot where the sensor is in good contact with the product. So this is mandatory. We need contact in opposite to the NIR technology, and then it will run. It will run for a very long time. It needs to be calibrated because please don't forget, we are an indirect technology. It needs to be calibrated once, but once it is calibrated, the calibration lasts for a very long time.
Okay, thank you. I'm sorry for the guests who just arrived in the room. Now it is already the Q&A session after the presentation. But if you want to join us and discuss about this energy optimization, I show you here. You have a link to my calendar. You can book a call. I'll make sure the proper people will be in line for us to show you what we presented today. There are two other questions I see here, and by the way, the other just feel free to type down your questions, because we still have 10 minutes planned for this meeting, if you'd like. So the question about the price, what is the price of the solution? We are not sharing a price catalog online or here in the webinar, because I would say it depends. But you saw maybe in the slide before, for example, the numbers taken from the pharmaceutical industry. They invested in 2 devices installed in the fluid bed dryer, and it represented an investment around 100,000 euro. So I would say having inline sensors and the machine to run it properly should be an investment from 40 to 60,000 euro. It really depends how much work has to be done on the line, and maybe also where you are located, because usually the team can also come to train the tool to measure your products, or we can consider having a remote commissioning if you're really far away. Sometimes we have local people to help us. Then I have to say hi to the team in America with online, and also our Chinese girl, Boya, who is online also. I saw her in the list. So yeah, I think first a discussion, a consultancy of the production line, and then of course a solution can be offered. And there's a specific wood question. What about solid wood boards? Say
1,001 kiln.
Yeah,
maybe one for me.
I think so.
Yeah, what we also offer is a system which is actually a transmission system. So here we don't have a little sensor, we have a huge measurement field provided by 2 antennas. And actually this is a little baby of mine, actually in its teenage years now already. So it really depends a little on what you really think of. So if you share a picture of such a thing with us, then we can start discussing it. And yeah, you're very welcome to send us a text, or and best would be to show us a picture, because it's just saying more than 1,000 words. But it's maybe possible to do that.
Yes, so I can add maybe for wood boards like MDF, HDF, or particle boards, we have many installations worldwide already. So this is a known application for us. And you mentioned in the range of 1 to 5% moisture. So this is the typical moisture, sometimes a little bit higher, but this is definitely one of our installations where we have very good experience with. So we are pretty sure that we can provide such a system for you, a solution for you.
Mm-hmm.
I have added the email. I mean, you can write to me. I think you received the email from me, and I'll make sure I have the proper people to join a Teams call if you like to go further. Yeah, a question: are you doing the density compensation in the sensor or with a separate device? That's a question for Henrik.
No, it's that's the cool thing about microwaves, because should I go into physics again? Maybe a little bit. I mean, microwaves have 2 properties. It's the wavelength. So if you imagine a wave, then it has a wavelength and also an amplitude. And we can measure both at the same time. And these 2 pieces of information allow us to measure moisture independently of the density, and density independently of moisture. That's the cool thing about this microwave range, which is not possible for capacity and many other solutions. So this is really a key feature for us. So all one at the same time.
Yeah, and that's what makes it particularly precise, I think.
Tremendously.
So to answer your question, there's no separate device we need. We measure moisture and density with the same sensor. There's only one sensor, and this is in this example, this is our planar sensor. So he can measure both in one sensor.
Oh, maybe we missed a question. That was for the. We have still people arriving in the room. Hi. So as I said, a recording of the session should be available. If we can share to the people who were a little bit late, maybe trying to find out the link in their email. Yeah, in batch process rather than continuous process. I think that the question was related to the former one for the wood boards. Huh? Yeah, so this was already discussed. Okay.
Yeah, to answer this a little bit further, for instance, if this would be the MWT, this is usually used for bales and boxes, so why not for kilns?
Yeah, usually we like the challenge. I mean, I'm not sure I like the challenge, but this team never says impossible. So the nice thing is I've been working with them for almost 2 years now, and I was in charge of trying to find new applications, and the team is always willing to test and check. So anything new is always nice to try. So don't be shy to ask. And yeah, sometimes we can even get samples. When it comes to be solid wood boards, might be more difficult, but yeah, getting samples, doing the tests, how it reacts with microwave is always a nice thing. So just yeah, feel free to ask further discussions. I don't see any more questions, so maybe this is where we wrap up the session. Yeah, I would just say thanks to Ingmar and Henrik, because yeah, as I said, webinar is not something we usually do often. So this was nice having you online, both of you. Thanks for your help.
Yeah, thank you.
Yeah, I'm happy to do this again.
You're welcome.
Welcome.
Very good. Then this is time to say goodbye. You can use the academy@TEWSworks.com email address if you want to get the presentation, if you want to get the recording of the session, and if you just want to discuss your process, your production data, just click on the link here. You'll be able to book a call with us. Thank you, everyone. I see people are already going out of the room, so have a nice afternoon or a nice end of the morning for the US guys. Good night for Chinese people. I think there is only one who's located in China today. Thank you.
Yeah, thank you very much.
Goodbye.
Yes, goodbye.
Goodbye.
Okay, you can leave and the yes there. That was not